and here let's move. We have one more folder is there, not the snappy. Check it out. In Hadoop DurgaSoft we have compression, and we have map reduce compression program. For this we already have the jar file. Let's take it out, and here we have to take the input also. What is the input file? Batsman scores. Like we have some batsman names, okay, and it is the scores against on which country, and we are specifying date. Like this we are mentioning the things, and here we have to get both the things, input data and compression logics to our LFS. Yes, let's copy compression here. Again the folder name is input. In input we have the batsman scores.txt. we have to copy to the our parent directory. Same thing, but I don't want to, I already copy the input data, comp / I want to copy jar file. The jar file name is compress Kodak. Compress Kodak.jar. I want to copy this also to the our parent current directory. Let's check it out. Both the things are there or not. Yes, compress Kodak.jar and batsman scores. Let's execute this both. Can I directly execute the map reduce program? No. The same phenomena. We have to move the HDFS. We have to move the input data to our HDFS directory. Like this itself. Hadoop fs minus. Let's check out what are the folders are there. We have a lot of folders are there. HDFS folder 1, HDFS folder 2, and MREX2, MREX3. Like this, we have a lot of things are there. Any one of the folder I want to copy. Let's copy Hadoop fs hyphen put. Put is used to copy the content from LFS to HDFS, and the input file name is batsman underscore scores.txt, and the HDFS directory name is, let's keep it out, we already have it, the first folder HDFS folder 1. In any folder you can do it. You can, or else you can create MR example 4 or 5 in the map reduce program. Then you can create in the HDFS in the same name, and you can also copy the content. I want to see the file name. By using which command? Okay, to see the content of the file means we have to use the cat, and the file location is HDFS folder 1. Yes, we got it. We have Sachin, Dravid, we have a lot of things up there. Yes, we have some of the names. We have the how many the guys are there. Yes, then check it out. the both the things are there. The jar file is already there in the LFS and the input data is already there in the HDFS. The only thing is executing a map reduce. Hadoop jar, the jar name is compress Kodak.jar and the input file location. Before going to input file location, we have to give the driver class name. What is the driver class name we are using? Yes, driver only. And here I am performing ggip Kodak. Okay, any one of these things, snappy or ggip, you can perform anything. Let's check it out. Is my package and the class name is driver. The destination is and the input file name we have to keep it out, right? Slash hdfs folder 1. The input data is batsman. What's the file name? Batsman underscore scores.txt. Scores.txt. And the destination folder I want to keep it out is like mr compression output. Let's check it out. Here we are executing both the things, mapper reducer, and after performing the reducer output, I want to keep it into a some compressor logic. Here as the compression logic, I am performing the logic name is algorithm name is ggip Kodak. We have to clearly mention ggip Kodak class, fine, and I want to perform compression. If you want to, if the data is already compressed, if you want to decompress, means we have to use decompressor Kodak dot class. Same thing here, fine. And if you see the mappers and reducers also, check it out what we are doing with the mapper class. As part of the mapper, I am also same thing. I am by using string tokenizer, I am dividing into tokens, and I am dividing into a with the player names and how many scores he has given. As part of the runs, I just passing player name and runs as part of mapper. And check it out reducer in what I am doing. And here I am manipulating the scores of individual batsmen. Let's check it out what is the output we have. We done the map reduce program. The output location is mr compression output. Check it out, Hadoop fs -ls mr compression output. Like this we can execute the things. Check the content. We have the data which is called in .tar files. Check it out guys. Interestingly, the file has an extension with .gz. how you are got this till now we have just only Potter files itself, but here we got a .gzip. Why means we compressed the file in a gzip format. Fine, let's check it out. Let's check the content of this file, whether this is compressed or not. Hadoop fs -cat and the file name is mr compression part zeros.gz. If you want to see this compressed file means we are unable to see. Why means it is already, the file is already compressed. Let's check it out. This is the file name, this is the file content. Have you got successfully completed the output, right? Are anyone able to understand? This is already compressed, we cannot able to understand. But the thing is, if you want to convert into normal text, we have a command is there, Hadoop. Let's clear the screen. Hadoop fs, we have text command is there. Fine. By using text, I am converting to the compressed format into a normal textual information. That is what we take it by the text command in Hadoop HDFS. See, if we aren't directly be able to see the screen means no, I am unable to view the things, and the data is already in compressed. And whenever we are taking the care of whenever we are executing things with the text command, we are able to see the exact things. Just I am doing the how many scores we have done with the people, and we already done the sort and shuffle phase. For that purpose itself, we are getting the order. We are maintaining order of the batsman names. The way it is starting with a D, that's why he moved in a starting person. Like this, we can perform the compression logic. If you perform the snappy, the extension for the Potter file will be snappy, .snappy. Fine, LZ2 means .LZ2. Like this, we can perform the compressions and decompressions. Fine. I hope you understand how to execute, how to work with the compression logics and compression algorithms in MapReduce Hadoop. Fine. If you want to miss directly, you can copy this, you can transfer this Potter.gzip file to the anyone from their end as the data node purpose, or that client side they will uncompress easily based on the text command or something. They can have some decompression algorithms also, we have some in Hadoop MapReduce. Fine. And let's check out the compression. After completion of compression logics, you people are efficient in the MapReduce program. Fine, and we already seen that what are the things are there, everything we have done with the MapReduce life cycle. And here very interestingly, as part of the MapReduce, still some of the things we have missed, that if we have if you go on for architecture level means we have name nodes and job data nodes which are maintaining the task trackers, name nodes which are maintaining the job trackers. Fine. The job trackers in name node will always initiate the task, right? Suppose the task tracker is not available. Fine. Then what it will do means immediately it will search about next task tracker which are available in the Hadoop. But here, before going to that, as part of the basic thing means it will maintain minimum number of attempts. Fine. The minimum number of attempts is 4. It will search for the number of, if suppose any one of the mechanism or machine is not working means the maximum it will find about 4 attempts to check the task tracker is working or not, and to check the reducer available or not. Fine. On top of this, you have already seen the MapReduce data types and all things, and the remaining programs that also we have seen. And we already seen the mechanism to check to stop the reducers. I want to see only mappers output. Then we have to use the concept called, we already see the concept called setNum reducer class, or else we can also perform in the hdfs site.xml. We can configure the variable called dfs.replication. There we have the implementation, the number is there, you can change it to the whatever the size. Default replication factor in the hdfs is 3, you can also change it to anywhere. I hope you guys understand. And if you want to check the status of the Hadoop cluster, then we have one command is there, hdfs dfs admin -report. The report command will give the complete structure of our Hadoop cluster. Let's check it out. Check out DFS remaining how much space we have in the data file system, fine, and how much space I am using. Just we used the 216.11 KB. It is given in the ratio of bytes, fine, the entire space we have in our system. And nodes, we have only one data node is there. For that purpose itself, we are maintaining the replication is only 1, and the compression decompression states will be normal only. We didn't use any configuration level. And if you check it out, how much space it is occupying, all the things, you can maintain the things. To check the live data nodes and all things, what are whether they are performing very well or not, means we can check with the report. And suppose we have already created one file, right, hdfs file name. The file is, suppose as the hdfs part, we just copied batsman scores.txt, right? We are copied in a hdfs folder one. Let's copy this and check how many blocks are allocated for this batsman file. Fine. To check for that, we have to use the fsh command, fsh, to check the number of blocks for assigned file. fsh, and the attribute name is block. The folder name is the file hdfs file. We have to keep it out. For only hdfs file only we have the blocks, right? Yes. Let's check it out. The things will be happens. Yes, here we have to use the things like the main class file fsh. Let's check it out. We have some other mechanism is there. Yes guys, here we tried with the, if you want to check the number of blocks, it will be allocated by the single individual file in hdfs, means yes, as part of the 1.x we need to specify -block, but in 2.x no need to specify to check the how many bytes are allocated. I am working with the Hadoop 2.x version. Check it out. First of all, before going to that, if you better understanding, check the contents of a sample.second.txt. It has, I hope it has only one line, single, it doesn't multiple couple of lines. It has only single line. This is second file in Hadoop. That's yesterday we have created this, and check it out here. Total size is, it has only 30 bytes of memory it is allocating, and total number of blocks is only 1. Why it has taken only 1 byte? 1 block means it is the file size is less than 64 MB, and that's why it takes only 1 block itself. Fine. Over replicated, minimally replicated blocks are only 1. Why I am taking the replication factor is only 1 means here we have only 1 data node. Check it out here. Number of data nodes are only 1, and here we have only 1 block. For that purpose itself, we have to take it out. The replication factor is also only 1. At least we have 3 data nodes, means it will maintain the replication factor as 3 defaultly by the Hadoop driven framework. And here check it out the racks, number of racks. I already checked it out, I already given the information about rack awareness. Whenever we are taking the data and whenever we are storing the data into the HDFS, it maintains the racks in terms of storage areas. Fine. This is also a physical memory areas. It will divide into a racks as a logical paths. Okay. Based on the racks also you may fetch the data. What is the advantage of dividing these into racks means to achieve the best optimization and best performances. Well, basically whenever you are giving the replication also related to these racks. Let's check it out. Suppose we have 2 racks are there and 4 nodes are there. In a single rack we have in each rack we have 2 multiple nodes, and for that purposes we have 2 individual racks and 4 individual nodes are there. Here if you want to optimize this rack awareness and if you want to maintain the replication based on the rack awareness principle, means at least in a rack we have to maintain 2 replications, and another replication, third replication is also there, right? As the replication factor as 3 means at least 2 replicas we have to maintain in a same rack, and in another rack we have to maintain the third replica. Fine. That is what the advantage of rack awareness to get the highest optimization. By keeping the minimum 2 replications in a single rack means, first of all it will find out the one data node which are available for the next client request, and here if we suppose suddenly the data node 1 is not available means it immediately checks for the remaining data nodes, okay, which has the replications of in a same rack number. Fine. Suppose it is also not finding means then only it will search about the another rack. For that purpose the data nodes we are arranging in the format of into a number of logical racks. This is what the rack awareness. And to check the number of blocks, we already seen the command is Hadoop FSCK and the file name which is included in the HDFS. We can check the only Hadoop FSCK will only works with the HDFS files, while means the only block creation, block allocation will be happens for HDFS. We cannot find the LFS commands. That's what entire the concept of rack awareness and blocks. How to check the number of blocks will be allocated by the individual file. Suppose you can take some 100 MB file means it may take 2 multiple blocks based on the 64 MB size, and you can also check the how many racks and how many data nodes are there. We already seen that. And we also worked on the administrative commands like DFS admin, okay, and how to say and we are already done with the safe modes and all things. Like that we can check the rack awareness and number of blocks of a particular HDFS file.